So this is our demonstration video on regular expression for our course B06 on using Python packages. So in this part, we're going to import this library called RE, which stands for regular expressions. So in this example, what we're going to look at first on the slides before moving on to live coding is we're going to assign some vector, some string called string2, and we're going to give us this sequence of letters that's kind of similar to an accession number. And as per the introductory video, we're going to use this function re.package. So that's coming from this package. We're going to use this function match to match this expression with a particular set of criteria here. So we're taking in string2 as our input into rematch. And this is our regular expression that we're using here. So putting in quotes that we're having the R to match this this sequence of characters which are arranged as having at least a word or more here for NM, and then a digits or multiple digits here at the end here. So this is one or many digits at the end here, separated by underscore. So we're putting the digits in round brackets here, and the same with the word. We retain those in the groups for M1. So we assign this output to M1 that contains a group item, which we can extract to print out these outputs as elements 0 and 1 respectively. There are other variations that from the same package. Sub is one of them, and that takes in 4 arguments: the pattern, the replacement, the string, and then optionally the number of instances that we want. So if we have S2 here, string 2 has at this start is a greater than symbol than A to B to C. If we substitute the spaces with a dash dash for S2 as our input, you can see that the spaces here that we should get dashes in between each of them, which we should do on the right-hand side. And then we have the same string, but we do it twice with a single dash. We'll get the one on the right. We have a dash twice, then a space with nothing, and a space with no change again. And then if you substitute the greater than symbol for nothing here, and just do it once, we'll get the output like we have on the right there. So that's resub as well as rematch. Rematch, resub, and research. That takes in just 2 arguments, the pattern and the string. So this will search to see if that pattern is present in the string. So it returns true or false. So if M2 exists, then we found the pattern inside the string. And we say NM is in this string. In the same way, if we have some query ABC, we can research a query given our string and say, yes, it is in there side there if that evaluates as true. So that's rematch, resub, and research. So for matching, substitution, and just searching. There's another examples of this where we have the dot as our query for the string, and therefore we would get to see if there's output there. And the same for if we see if it starts with an N, that will print that if it's true. And the same if we have 1 or 2, 0 or 1 copies of M, it will say that's inside there. And then we have another example where we have a backslash s for a space to see if that's this string here, or either Z or X. And is another example. We can do the same with numbers. So if we have a string here and we want to search for numbers in it to see if it has a number anywhere, we can use the square brackets to refer to 0 to 9 to do that. And we can also use a more complex expression here. So you see here that we have several different digits there. We've got a word, a space, at least one space, digit, space, and then a word, which kind of corresponds to what we have above. We can see that if we have research like this, we're going to see if that string matches there, and that'll print true if it has this exact match. So that's research as well as rematch and resub. And we have refind all as well. That takes in 2 arguments, the pattern and the string, like research, and it finds all the occurrences of the match. Research finds the first instance only. So we want to find all the ATGs inside some big string of letters. We can therefore print out the number of matches that we find and the actual patterns that have been matched to as well. So let's go to PyCharm where we can actually demonstrate this using code. So let's look at this example where we have a string 12121, we can have this code. So we have the function s.replace. So we can take on board, let's say we want to match W and O. We can replace that with whatever we want and see what this will produce at the end. So let's run that and see what it shows. It says 1313. So replace WO with re. In the same way, we can do that multiple times. So maybe we can just do it once in this case and see what happens. Now we have 13121. It's just replaced it once. So that's an example of how we can use replacement. We also have resub as well. So resub works in the same way, except there's a slightly different structure. So we have our this is struggling re.sub, and we're going to take on board the pattern we want to match. So that might be any, the replacement might be nothing, and then we're giving it the string we're trying to use here at the end. So if we run this with the appropriate number of round brackets at the end, we'll see that re was not defined because I didn't import the package. So what I have to do is to make sure I have import for re at the start here, and then run this. Now we'll use that regular expression library to execute this function here. So you can see there any is now removed from there. So for example, if we do that, we replace open to open to open. Another example that we had was rematch. So with re.match, we could have more complex patterns that we try to match here. So we don't have S at the, we have S at the end. We have no replacement here. So we're just matching to see if we match any inside this pattern here. And if we do that, we get none back because it will try to give information on this pattern. So what we might do is give a particular, say that we're going to split on this set of characters and see what it'll give us back. So if we run that again, we get none too. So what we can do is try to match this more effectively by looking at multiple matches for different letters. So if we try this with the having multiple letters together, it's indicated by the plus sign, and run this, we'll find that we've got some sort of object. So what we need to do is put this in round brackets to capture the output from this match. So if we do that, then we'll find that we get a rematch, an object here containing a span. So what we need to do is assign this to a new variable. Let's call it M5 for match 5. And then we're going to use the groups to extract information from that. So you see here we have groups, and if we run this together, we need to put a print sign at the start. We can see there that I need to have the right assignment character. We see that we capture 1 inside there. So 1 is inside there, and if we put in a space and then a \W for the next letters for 2, you see you get 1, 2. So what we can do is split these round brackets up to capture each item individually if you want like that. So now that becomes an array. So if we wanted to do it for the whole set of letters, we could just do that 5 times like that and have 1, 2, 1, 2, 1, 2 all broken up into different groups. Obviously, this is not the most efficient way of splitting these up, but this is a way of using rematch to understand better how we can use that function. Another query you would have is research. So research is like this. We just have a search query that we want to apply, and then we put that inside our round brackets. So you have our string query here. I might search, do I have n? So as you saw there, the simplest way to do this is simply to have an if statement with the colon and print yes, if that's the case. So if we run this, find we say yes. If we say Z, we get nothing. If we try O or Z? We say yes. If we say Y or Z, it says no. If we check for any numbers, 0 to 9, we see none. If we check for the letters A to Z, it says yes. So you can see there we have exact matches. So do we have this match of exactly W and 0, W and O? We see yes, WO with the space, yes. If we check that, if that is there more than once, we'd have to use final instead. So you can see how research can be convenient. We might use one where we check if it starts with a O, somewhere inside there, and run that, we see a yes. If we say, does it end in an O with a $sign, it says no, it doesn't. If you see if it ends in an E, we have no match there. So the ending it with an E. So what we need to do is put this the correct way around, which is E and $. So if we run that, then we see yes, we have a match. So that's an indication of how we can apply our research to these sort of string matching patterns. And we can make them more complex if you want as well. So we could have a word, multiple words, and then a space and multiple words again, like this. And we see that we get a match for that. But if you remove the space, oh, we do get a match. So let's put in 2 spaces. We don't get a match. And then our final one was find all. So that finds all the instances inside this string. So we're going to remove this part, move that part, just have find all. And what we're going to do is find all the instances of O inside this string. So if we run that, it'll execute, but it won't tell us more about it. So if we print this out, we can find out more about what this has recovered. So you can see there, it recovered all the instances with O there. And if we do for ON, we'll find that there's 3 instances there. If we do it for WO, it's 2 instances there. If we do it for simply the space, we find we've got 4 instances there. So we can have a print on the length of this output. And we can see there we have the numbers of matches we have there, 4. If we do it for something that's not inside there, like Z, we get nothing. No length is returned. So we can use this for pattern matching indoors areas. So that's the end of this video.